Good morning. Good morning to all of you who are here, and welcome to all those who have joined online from across the globe. Thank you for joining, and today this session is about fire and evacuation modeling for a large commercial building. Let me introduce Mr. R. Balakrishnan. He is Vice President and Head, MEP Design, Buildings and Factories Division of L&T Construction, and he has 38 years of experience in construction, and his extensive experience in MEP design covers large and landmark projects, airports and stadiums, hospitals, commercial buildings and data centers. He has joined online from Chennai, India. This is myself, Munirajulu. I am responsible for CFD, Computational Fluid Dynamics, in Buildings and Factories Division of L&T Construction. I have 28 years of experience in CFD technology, in design, analysis, validation, and optimization. And I am responsible for performance-based design for design and build projects in L&T Construction. And I have worked on various projects, airports, stadiums, commercial buildings, high-speed rail stations, data centers, all to do with CFD. And I am extensively using the egress and smoke management analysis as well. So let me give you an overview of our company, Larsen and Toubro Limited. We are based out of India, and we have presence across 30 countries. We are into technology, engineering, and construction. And L&T Construction is the construction arm of Larsen and Toubro Limited, and it is the largest construction company in India and also one of the top contractors in the world. So we design and build commercial and residential buildings, hospitals, public spaces such as stadiums and convention centers and large airports. And our design and build capabilities span across the entire gamut of construction, civil, mechanical, electrical, and instrumentation engineering. We have designed and built quite a number of landmark and iconic projects in India as well as overseas. One of the recent examples is the world's largest cricket stadium that we have completed about a year back in India. This would be the presentation flow for today. I will start with the problem statement as introduction, then I will give a brief description on the building and what is our project goal and what is the methodology that we have adopted here, and how we went about egress simulation using Pathfinder and smoke simulation using PyroSim, and then the results from both of them, and then how we actually use these results to conclude about the adequacy of the design. So you can see the building model on the right side. The building architecture is such that there is a retail space here and there is a office tower here, and the architecture is such that the retail and office tower, these fire escape staircases are interlinked. But the local code NBC 2016 requires that these occupancies, retail and the business, they have separate staircases and should be independent of each other. And this is a unique situation which makes it difficult to comply to the codal requirements. So to overcome this problem, we resorted to performance-based approach for life safety, and it also actually gave us opportunity for optimizing the number of staircases, which I will speak later. So this is a building. Built up area is 76,000 square meter, 95 meter tall, and it has one office tower and one retail shopping mall. The shopping mall has ground plus 4 floors, as you can see here. This is the shopping mall. And the office tower has 15 floors. So total there would be 19 levels, and then there are 2 basements. And the fire escape is addressed by fire escape staircases, four numbers of them. And there are also refuge floors at 5 levels in the office tower. And the final exits for evacuation is at ground floor as well as the first floor. And apart from that, there is one external staircase. So this gives the detail of the layout of the fire escape staircases. These 2 are in the office tower. These 2 have 2-meter staircase width, and these 2 are in the retail shop area. One of them, this one is 3-meter width, and this is 3.5-meter width. And for the project goal is life safety, and the smoke exhaust or the smoke management strategy and the occupant egress strategy. These are very important features of fire safety strategy to ensure life safety in the commercial building. And this requires us to calculate egress times, and also the time during which the safe conditions are maintained by the smoke exhaust system that we have designed. And then comparing the A set and the R set will tell us if the design of the staircases as well as the smoke exhaust system is adequate for life safety. And for egress calculations, we have used Pathfinder, and for smoke simulation, we have used PyroSim. And while the egress calculations are carried out for the entire building, the smoke simulation we carried out for critical areas. For example, 2nd floor in the retail area and 14th floor in the office level. So we get R set and A set. So these are the inputs for Pathfinder simulation. We have the occupant details for each level, and then we have specified the velocity of the occupants and the definition of the occupant: cylinder, diameter of 0.45 meter and height of 1.7 meter. These are default values. And for the FDS PyroSim simulation, we have considered fire source located at 2nd floor. Retail fire we have considered, and we have taken the fire size data from BS 7346, which is 3.125 megawatt, and we have considered a soot yield of 0.1 kg per kg. And for office fire, we have considered fire source, workstation fire source at 14th floor, and we have taken this fire size data from building and fire research lab test data for the workstation, which is 1.8 megawatt. Here again, we have taken the soot yield of 0.1 kg per kg. And acceptance criteria, we have considered visibility greater than 10 meter at height of 1.8 meter, and temperature, smoke temperature should be less than 60 degrees Celsius at a height of 1.8 meter. And the toxicity calculations we have not done, but if the visibility is more than 10 meter, it is deemed to be acceptable. Toxicity levels are deemed to be acceptable. So here we can see the Pathfinder results for the retail space, the 2nd floor, and the occupant distribution at time 0. And then as the movement proceeds, evacuation proceeds, so we can see the occupant distribution at 170 seconds. The last occupant to exit from the 2nd floor to the fire escape staircase is 170 seconds. And the total time required for the last occupant to exit this 2nd floor is 445 seconds. I have not mentioned that value here. So here we can see the animation of the occupant movement in the 2nd floor retail area. Yeah. So there are 4 staircases, and all the 4 staircases are used by the occupants, but not in the same way. Looks like the one of their staircases, more occupants are going towards this staircase compared to other staircases. But it is good to see that all the 4 staircases are being used by the occupants. Yeah, the last occupant to exit from the second floor is about 170 seconds. So these are the results from Pathfinder for the 14th floor. Occupant distribution at time 0 and then at 108 second. For the 14th floor, the last occupant to reach the fire escape stair is 117 seconds, that we can see in the animation next slide. So here again there are 2 staircases, left side 1 and the right side 1 staircase. But we see that most of the occupants are going towards the staircase on the right side. And then when we investigated why it is happening, actually there are refuge floors on that side of the building. So the definition of the refuge floors, I think, is actually causing this uneven distribution of the occupants. So these are the results from PyroSim smoke simulation. So here we can see the visibility plots and the temperature plots with time section views. So with time we see that the smoke layer is actually falling down to the occupied space, as we can see from the visibility levels, but it is more than, it is much above the occupied height of 1.8 meter at 10 minutes or 600 seconds. Similarly, temperature, smoke temperature towards the occupied area is increasing, but it is much below 60 degrees Celsius for the retail fire. And when we look at the horizontal section views, we see that the visibility and the temperature plots, they are meeting the tenability criteria. Visibility is more than 10 meter and temperature is much less than 60 degrees Celsius till 600 seconds or 10 minutes. And when we look at the results for 14th floor, for the retail, actually there is a typo here, it's not 14th floor retail area, it's office space. So here we can see again the visibility plots and as well as the temperature plots. The visibility levels are actually, the smoke layer is actually falling down towards the occupied area, but it is above the 1.8 meter level, and similarly the temperatures are above less than 60 degrees Celsius till 175 seconds. And when we look at the horizontal plots here, again it gives a clear picture of what's happening to the visibility and the temperature. So here also we see that till 117 seconds the occupied area is free from smoke and the temperature is well below 60 degrees Celsius. And when we look at 175 seconds, some areas are showing visibilities of something like 7 to 8 meter. And for the purpose of comparing the R set, A set, we have actually taken this 175 seconds here. The reason being, when we look at the people evacuation vis-a-vis this value, we find that by 175 seconds, the occupants have actually left that place. So we have taken this 175 as the A set value for this. So in conclusion, smoke for the retail floor, smoke visibility is more than 10 meter within a height of 1.8 meter from the floor level for a duration of 10 minutes. We simulated, of course, up to 10 minutes because we found out that it's enough, and smoke temperatures are less than 60 degrees Celsius within the height of 1.8 meter, except near the fire source. And so from this we see that tenable conditions are maintained for a duration of 10 minutes. So we have an A set value of 600 seconds and the R set is only 170 seconds. So the smoke exhaust design as well as the staircase design for the retail area is quite adequate for the life safety. And one more thing we have seen here is that the total number of occupants is for this floor is 1,587. As for the NBC code, we would require a staircase width of, total staircase width of about 16 meters. But by doing this analysis, actually we have zeroed in on only 5 staircases with a total width of 12.5 meters. So the code requires close to 16 meters, whereas by doing this analysis, we have demonstrated that 12.5 meter is adequate. So this actually gives a scope for optimization, and the total staircase width is reduced by about 20% here. And when we look at the office floor, here again, as we have seen in the results of PyroSim as well as the Pathfinder, smoke visibility is more than 10 meter, and smoke temperature is also less than 60 degrees Celsius. So this gives us a ASET value of 175 seconds, and RSET is 117. So here also we find that ASET gives a safe margin over RSET. Therefore, the provisions of staircases and a smoke exhaust system is adequate for life safety. And again, by doing this performance-based design, we could conclude that 2 staircases with a total width of 3 meters is sufficient for egress of 182 occupants. So, so this is a case study that we did it using PyroSim and Pathfinder actually to overcome this conflict of codal compliance. So with this, thank you so much. Yeah.
Thank you. Welcome.
Morning to one and all.
So we have a couple of online questions first, and then we'll see about questions in the room. The first question is, has stack effect been taken into consideration in this model? And if yes, what kind of boundary conditions are used, like velocity, volume, flow, pressures, etc.?
Yeah, so for the 14th floor, when we are doing the smoke simulation, the staircase pressurization we have taken into account by giving a velocity boundary condition at the lobby pressurized surface. If that is what the question,
Okay, I think that covers that. What was the evacuation strategy for any handicapped or disabled mall visitors?
If I can answer that, yeah. So we had a specific elevators, which was a fire elevator, which we need to direct this handicapped people to that particular place within this period of evacuation time. We had kept to 10 minutes evacuation time. So that was the way of going out. So what happens is this particular space where this fire lift is there, it is totally pressurized and enclosed. It's like a complete, like a 4-hour fire rated area, so that no fire gets into that space. That's how we were evacuating this handicapped people. Okay,
thank you. And then what did you consider as an alarm and alarm and detection time?
Yeah, actually in this project, what we have considered is the evacuation starts, the zero time for evacuation and the fire start time is the same. So the assumption is that detection and alarm time, the zero time actually is after detection and alarm time, and the pre-movement time is assumed to be 0. So yeah, that's how it has been done.
Yeah. So I'll just add it. We had a complete automatic fire detection and alarm system, which will be an instant messaging through the PA system. So that's how it will be immediate in case it senses a fire. Inception of fire itself, it will pick up. So I think that is how we have designed the system completely. So it will be practically immediate, the evacuation command from the PA system. So that's how we have taken it as a zero time.
Okay, and then there's a question about your agent profiles in Pathfinder. Did you use distributions of size and walking speed for them, or are they all the same profile?
We have set the walking speed as 1.19 meter per second to start with, but Pathfinder anyway, it will take the speed based on the queuing and jamming and so on and so forth. And the occupants shape, we have used the default values, 0.5 meter width and 1.7 meter height.
Okay.
Yeah.
What grid size did you use in FDS?
Yeah, for fire, we normally, we consider a very refined cell size. Usually, we use something like 0.25 meter for fire area, and then slowly we, make it bigger, yeah. 0.5 and then maybe 1 meter depending on the space of the building, yeah.
Okay, and then kind of related to your earlier question and answer, but did you include pre-movement time in your RSET?
No, that's what we have.
That's zero.
Zero.
Okay.
Yeah.
And then thank you for your presentation. For the evacuation at upper floor office space mentioned, have you considered the saturation of the staircases due to occupants from other levels entering and filling it? This may create a situation for occupants to bottleneck at exit doors and would be unable to flow out smoothly into the staircase. So do you account for any kind of obstruction in the stairwell of other occupants from other levels?
We have not considered anything specific, but we have allowed the occupants to go to any exit. And of course, the definition of refuge floor, that what we have seen is that actually is creating some kind of the flow that we were not expecting actually. The 13th floor, the refuge floor is on the 13th floor. So 13th floor people, some of them actually tend to go towards the refuge floor. And then 14th floor, most of the people try to come to the staircase that is close to the refuge floor. Yeah, so, the floor-wise, there is some, people, coming and then these people jamming and, that I think it was realistic observation, yeah.
Yeah. So I'll just add on to what he said. See, all our staircase, right from the top to bottom, is designed, I think minimum 2 meter is the criteria, and we have checked it when everybody escapes in case of fire. So that sufficient width, staircase widths are provided, and it is pressurized for all of them to move down smoothly. So the population, based on the population, I think there is a criteria of 5 minutes or something for all of them to come down. So it is sized adequately for the population of the building, both in case of retail and the office buildings.
Okay, any other questions in the room? Nope, okay, well, oh, yes? No, okay. So thank you very much.
Yeah, thank you.
Thank you for your talk.
Yeah, thank you.